Hi guys, morning.
Hello, everyone.
Morning. Okay, let's give people a minute maybe. Join us. Started 10:03. Let's see.
Hello, anybody on?
Hey Tony, everybody.
Yeah,
Do you hear us?
I hear you. Do you hear me?
All right. Yep. Oh, I should have said no. Just uh,
I could start yelling. Can you hear me? Can you hear me now?
no, still
What?
don't hear you.
What?
Yeah, exactly. Okay, so let's get started. I think we have a quorum. So today is a test design kit meeting. And I'm glad to see that we have Rajesh and we have Rudy from Cadence. Tony, welcome back. So last time we talked a little bit about we didn't talk about specifics, but kind of we talked tactical. What do we want to do about tests? So who wants to start with that discussion and share some thoughts? Maybe okay, I'll point a finger. Bala, maybe you can. I think you're the expert here, one of the experts, so you can take us into the test and some of the issues you we were talking about last time.
Yeah, that is right. So we were talking about this the TDK development, and so what are the inputs needed in terms of capturing the data sheet for um, the pin nodes across the chiplets at the package level. Of the so we discussed about the two different standards like 1838 and as well as 1149.6, right? So those two standards are giving the enough information about how we are handling this serial access for the test mode programations through the IJTAG, and then um, accessing the different partitions through the like a parallel interface, like the SSN, for example. And then the 1149.6, it gives some information about the AC parametric test for the uh, different electrical characteristics of the test. So there are information about how what are the details that which is needed for the TDK in terms of setting the timing parameters and the electrical parameters across these digital and electrical pins, right? So those things are already spec'd out in those uh, standards, and there are which is also adopted across the EDA tools when they are generating the patterns. The style patterns are traditionally used to write out um, all these timing like waveform kind of details, and also uh, apart from the style, BSDL is another language which is widely adopted. So what I believe is like that can be a precursor for um, the the CDXML generation, and where we can incorporate all the pin attributes for the test mode, like what is the default values across the pins, if it is the digital pins and the clock pins and the any configuration bits, um, we can come up with a table of content across the possibilities and on the for the different characterization tests related to those pads. Those are the things that I'm thinking through it. Like, so what we need to, what number of, in a summary, like we need to have a list of pins and the associated timing and the electrical characteristics and the default values and the range for the tools to come up with some rule checks for that, right? So that can be useful when any tools it's generating the patterns are running through those patterns for the verification and or the any DRC checks, we can utilize this language like CDXML as a superset, having, and which also can be useful to translate to the style or BSTL kind of vectors eventually. Right. So,
Right.
Well,
So,
this is all at the chiplet level that you're talking about.
yeah, it could be both chiplet and the package level also. So that way, the CDXML will be a superset of the style and BSTL, CTL, right? So all the characteristics can be put together, and it could be one central source of like a master, for example, like how the 3D blocks is dictating all the different package level attributes, right? So in the same manner, like we can have one central attributes of everything what SIP needs it, right? So it could be digital or differential pins, electrical pins, so everything put together. So now we have a category of pins, and we also understand the attributes associated with each of those pins for the across the timing and the electrical and so all the different flows what it needs, like, so that can be a one master, so a hash table kind of things that we can come up.
okay.
Do you have
So,
a template in mind for this? I think we should start at the chiplet level. Right.
Right. I have created a set of tables. Like I'm still working on it to merge it. Like I have the list from the style, and I have a list from the BSTL, and so I'm also trying to look at like for the differential pins, like how it looks like. The BSTL gives that some portion of the differential, but not complete scenarios. So that part I'm trying to carve out, and then maybe next meeting I can present. We can identify if there is any deltas that we need to complement, and so we can take it from there.
And how does this relate into what's in the current revision of the script for the TDK?
Yeah, the current revision, it has the placeholder for the set of pins and for the test mode values, things like that, but it does not extend. Um, for example, it's not a superset of style or BSTL, right? So it gives a generic overview, but it does not cover all permutation combination of the basic things needed across the style pattern or the BSTL generated patterns, right? So BSTL has a specific characterization inputs across the pins in terms of timing and or the AC related stuffs, which is not there in the style. And but style has few things like waveform related controls, which is not directly, which is not in the similar format in the BSTL. So like both are having like complementary definitions, and so I think CDXML will solve yeah, hybrid solution of both the scenarios, and it can be it can potentially become a superset for all test needs.
So BSTL is the kind of top level IO structural description of the test IO, right? For at just the very top level. And
yeah, that is
typically
right.
Those are used to check connectivity. I mean, it's normally used more for board level testing, right? To make
Right.
sure you can just
Right.
do boundary scan on the IOs for
Right.
the chiplet. So in this, or for the chip, on a PCB. So
Right. Because in terms of the power on for the products,
hang
like
on. So BSDL is an IEEE spec, right? So
right.
are we leveraging that spec, or are we trying to re-implement that in an XML format?
I don't understand what's the difference here. Like, can you? What is the difference between the leveraging and the with like? Yeah, I would say it's more of a leverage, like extend the same approach in the CDXML format, and like take all the pluses from the style and the BSTL. When we put together, we will know um, uh, like um, it's a more integrated solution of the.
I need to see a diagram. I think
Mhm.
most of the folks on this call are not experts. I think we're not as comfortable with just talking about this stuff. So if
Right.
you
Yeah,
have any
yeah. So yeah, I'll.
diagrams that kind of show or illustrate what you're talking about.
Okay, yeah, fair enough. Yeah, I can do that. Yeah. So BS, the thing is right. So the style and BSTL are meant to be for dedicated tests mechanisms. Like where when we go through the SIP level, like the package level, there is no integrated language, right, which will fulfill all the needs, right? So let's say if a tool is supporting CDXML, it's a master, and then the style and the PSTL portions are given for that tool, right? So that way, this will become compatible to 3D blocks kind of stuff. So for and the another caveat with this proposal is like where right now the tools are still like individual tools, like where across the EDA companies, so there are, for example, scan tools doesn't necessarily needs to support the differential pad definitions, so how are the pattern generation for the differential pads, right? So like having a one superset CDXML kind of tool like language in place, then it will give an opportunity for the EDA companies also to integrate those tools together and then create a hybrid pattern, right? So if they want to evolve some concurrency tests, like so they can still do like target those type of like a cross-domain tests. They can mix it up for the test time saving eventually.
Anybody else struggling with this? I'm having a hard time conceptualizing this.
I think what Bala is saying is that uh, um, the CDXML is going to drive the test tools in a way.
Right. Right. So
Right.
yeah. So
Yeah, Bala. So I think what Tony is trying to get to is if a definition exists already somewhere, we would rather not repeat it here, right?
okay. So yeah. So yeah. Let me come back with the completed document so I can share it. So yeah, today I was not prepared to talk about
Yeah.
this.
Okay.
Yeah.
Yeah.
So I think I will come back with like a couple of slides, sharing like what is the key areas from the style that we need to pick it up, and then from the BSTL what we need to pick it up, and how that merge solution will look like, right? So if we take that in picture and then show some examples of having the test time savings to target
Bala,
the concurrent test. Yep.
Bala, my one question is, I know you, before we wait for your slides, can you summarize in one sentence or two straight sentences, what are you trying to achieve? for
Okay, so
um,
today,
for David's purpose. I mean, for CDX.
right. So in summary, so we can consolidate and merge the boundary scan and the style related test features together in one format. So that way it can will open up the possibility for a concurrent testing, right?
Concurrent
So
testing of.
let's say if you want to schedule some memory based to the style pattern, and so that is involving the just using the JTAG to initiate the transactors and the memory based controllers, and then you can, instead of waiting for the memory based to complete it, and you can still go ahead and initiate any boundary scan related tests, like a AC parametric test for the pads, which is not utilizing the JTAG or not disturbing the memory based. So we can identify like a non-overlapped test features and try to involve some concurrency for test time saving. Instead of doing a sequential test, we can do a parallel test in this case.
What I'm trying to understand is what all you talked about, how it is helping the SIP and CDXML effort here. I mean, what you talked about is a very general thing. It can be done, but what is special you are working on for helping David's effort here? I'm not sure when you are building. I think we are going to get a lot of chiplets, and that's what the CDXML is a format where it's easing us to get into design. So I think design aspect is done, but test aspect is what I think we are trying to address in this meeting. So I'm still not sure of what is BSDL as a standard, as Tony mentioned. So every chiplet is going to adhere to that standard. So what is exactly the differentiating factor we are bringing here? Are we adding some language constructs to CDXML, or I'm not sure.
Well, let me tell you the way I think about this, and I'm not going to get into the details, but at a very high level of abstraction, if we go back to our charter, we're trying to promote an ecosystem, right, with the goal of having, reusable off-the-shelf chiplets. So we're driving standards to kind of facilitate that. So if we think about this from a test perspective, vendor A, vendor B, vendor C, they have chips, right? So we have formats that describe all the pins for those chips, the physical dimensions, the thermal characteristics. So for the chiplet level, the way I think about this is I want to have a machine readable description of the test methods that were deployed on this chiplet. Okay, so we're not trying to develop a machine readable format that DFT engineers can, implement DFT on a chiplet. I mean, that's what the EDA vendors tools do. So I don't think we're proposing a standard that's gonna, drive detailed DFT scripts, to do DFT insertion on chiplets. So from one perspective, I think the goal is just to, there's lots of standards out there and they're changing. So we're trying to articulate what test methods were deployed on this chiplet, where are the IOs and what do they do? Where are they physically? What is their electrical, pin name? And, from that, it would be enough information where an educated DFT engineer would know how to basically, know what tests are available. And then the idea is the chiplet provider would need to provide some mechanism to generate the patterns. If it's ATPG, maybe it's just, BIST is kind of a simplistic way of thinking about it, and that would be ideal. So, all right, you just set up these IOs in this configuration and hit run, and it's going to test, and your results come out here. That would be the simplest thing, but we all know that, testing these things is much more complex. So that's kind of the high level intent of what we're trying to do at the chiplet level. Now, at the package level, you've got all these chiplets, and they have different levels of they will invariably be using different test methods and methodologies. So the challenge to the SIP level test engineer is, how am I going to test this at the package level, right? So I know where the IOs are. I know that, I have chiplet A, B, and C. I have to figure out what are my primary pins that are coming, throughout the package, at the BGA level, and where do I hook them up, and how do I connect the test IO for each of these chiplets, so I have the ability to kind of do high-level system type checks, as well as execute the tests that have been implemented in each of those chiplets. That's what we're trying to accomplish here. And the first question I defer to the expert is that a realistic ambition? And if so, what we have today, how does that meet that high level objective?
Yeah, Tony, so today, for the system level requirements are not directly available in one database, right? So that itself, it's a very big ask to check everything related to the test patterns, whether it is in compliant with system requirements, right? So in the same way, the patterns also, there are multiple different formats, like the style and the BSTL and SVF. There are lots of formats, different tools based on the nature of the test, which are involved, right? So so if we try to, I was kind of trying to consolidate from the bottom up, where the from the pattern standpoint, we need to have a central source, so that we can translate any type of pattern to the CDXML format, and then we can create a database to check based on the left of our GDS. We can extract the timing and the electrical characterization things, and we can try to infuse those delays, or create some test method softwares or for the ATEs to help binding these values across the strobe windows, things like that, right? So
that sounds very, very ambitious to me. I mean, we want the format to have patterns. You're talking about actual patterns
right.
I'm not sure that's feasible and even desirable, right? Because these are open formats and machine readable. Do our chiplet vendors going to expose detailed test patterns? I think
you can put them in encrypted,
right? Yeah, so I think they need to be encrypted, and these patterns need to be obfuscated or encrypted at some mechanism. But I think those encryption methods really need to be built into the chiplet itself, right?
Right. So what I am trying to articulate here is, right, so where so for example, the SDE error, right, So those are related to there are differences in terms of the timing models versus the post-silicon and the interconnect paths, right? So we don't have a sophisticated timing models today, which will exactly mimic the post-silicon. So it could be either
When you
related to
say we're saying the DFT industry or
right.
AAA, which is really IEEE, that where all these test standards come out. So are you proposing we create a new IEEE standard to do this?
Okay, so in terms of, I'm not proposing to create a new IEEE standard, but I'm thinking more of a problem statement, like where the gaps are there, like so where we can propose some enhancements and the language standard for that, right? Where the um, extract today, it's more of a having a static timing check for the test mode with respect to the specific pattern paths,
All
and
right. So
how do we quickly correlate that
yeah.
for the
So
silicon?
Bala, how is this information handled today? What would I write in today's flow without having CDX ML to carry that information? How is that information transferred from one chiplet's test insertion up to the upper level test insertion? How does that work today?
Yeah, so today is so all these solutions are available, but at the within the chiplet level, at the partition level. But if you want to do a same thing like so, but today they are doing it is trying to do a extract the SDFs and then generate the patterns in parallel, and then try to do a typing JLS, right, to catch any problems with any paths like uh, so that will show in terms of like a setup violation or hold violation or recovery or removal violations, things like
Okay,
that,
so
right? But
so so
that is more of a like old school method for the SIP level interconnect path verification, because we don't have a compute power to load those type of hierarchies and or even block boxing the internal stuffs to minimize the load. Like the DFT industry does not have that much of bandwidth also to go and check that before tape out uh, to exercise those stringent paths, right?
okay.
And
I mean, you're talking about now back annotated timing simulation,
back
right?
under driving simulation at the package level,
Well,
because package.
So I mean, if we go back and look at the CDX, the chiplet design kit, one of the models to support static timing analysis, and if you have a static timing analysis, basically we're advocating to have a .lib model for the chiplet, so to kind of have a black box ILM type .lib model that would be used for doing more block to block kind of checks with an STA. And on a similar note, if you had a behavioral model for the chiplet, having provisions to support kind of timing arcs at a very high level, an ILM type model. So you could create SDC and do some timing simulation. So I don't think we're really doing anything in the format to facilitate that. I think that the idea is we're recommending that a chiplet provider provide that let's call it black box level. I like to make the analogy to a block within a chip, right? So in a chip, you have ILM models, high level models for each of the blocks, and you could do very simple type timing checks, for the whole chip. Look at setup and holds at those interfaces, but you're not looking at the detailed timing arcs inside. That's an internal chip problem. So it's primarily we're just looking at the chip-to-chip timing interfaces.
Yes, Tony. Like what you are mentioning is it is already there as a known problem within the chiplet, like a huge chiplets also. But what the gap for the SIP or the chiplet, the huge chiplets is like the 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 passive components are getting added at the chip the package level for some of the timing boards, which are not properly constrained or modeled for this type of timing GLS, because they cannot write out those passive components as a very long model for the GLS, right? So they exclude those RC network, everything, and then try to create some SDFs and then very log, and which does not work out of the box. Even if you try to involve some black box or gray boxes for the chiplets, try to minimize that workload for the GLS for the full LRM, like or partial LRM. It is still not covering the intended need, and people get to waste time in isolating the problems which are introduced due to this shortcut of gray box or the black box approaches, right?
If I remember correctly, when Joe Rennick was involved in some of the original work that we did on the what is now the JEP 30 and the white paper we did about talking about chiplet models, he was recommending, I think he called it a gray box wrapper, or a kind of a logical wrapper that really just had kind of the top level test interface, ignoring the guts of the chip. And if that was a design view that was provided for the chiplet, then the SIP designer could run very high level test patterns and simulations in STA.
Right. That works only for the hierarchical course story, honestly, where at the chip level or chiplet level itself, when you have fuses and securities or clock and reset, power controls, those type of complexities are involved. So those scripts doesn't work in the way it's supposed to be, because of this lots of aborted clocks and feed throughs, and lots of pros and cons with that methodology. But it works at the hierarchical cores deep inside the chiplets, not even at the chiplet boundaries today. And so people, DFT teams are really struggling, and many times they give up and get a waiver for this type of timing GLS today. Like I believe if we try to focus on that area, it will be really a good solution to solve some of the burning issues just towards the tape out.
So
that will be a really commercially successful work that if we try to focus on that area.
Bala, I have a question here.
Mm-hmm.
So I see where you're coming from. My question is, here we are trying to solve the chiplet as well as SIP problem, I understand. But is that the GLS, timing GLS is because it's done at the SIP level, and very few companies like Intel or AMD who are actually in-house, integrating in-house chiplets, they will be able to do that, all that stuff, right? At system and package level, timing simulation outside interconnect, right? Outside chiplets. So the balance, I mean, audience will be limited. I'm asking chiplet level, everybody will try to close SDFs, even forget about DFT, even they will close at functional level, right? So my
There,
question
yeah,
is, what
no,
is the
so yeah, you're talking about two different things, right? Where so you're talking about the timing closer methodology just from the
yeah,
STA standpoint at the SIP level, and then
correct.
how that is extended even for the functional timing GLS,
Yeah, I mean,
right?
and right
So
now, if you, no, no, I think what I was confused when you were
mhm.
proposing all these timing level checks, which is difficult, but at the chiplet level, everybody has to do it, right? As a chiplet provider, or
yeah,
the
within the
problem you
chiplet,
described.
the STA, the typing GLS sign off is there at the chiplet level, even at the SIP level also it is there, but there is no timing GLS attempted, at least in the Intel I have not seen any timing GLS at the chiplet level, like where they don't have yeah, a simplistic method of creating the netlist itself. They have a large problem there, right? So there is not even no timing GLS there,
No
right?
timing GLS at the chiplet level. That's what you're saying?
No, SIP level. There is no
Yeah. So
GLS. Yeah.
yeah. Okay. So now So that's what I was expecting. That SIP level means
No,
it's a
that's where
problem of the
they all
integrate.
these hyperlinks guys are facing this problem today, right? Where they are seeing a gap in terms of constraints. Like whatever the constraints they initially believed it's supposed to work, it is not working in the silicon, right? So now they are coming back and reviewing the constraints itself to
Okay.
see how these type of problems are occurring, and so they kind of do a trial and error method with SDA. But unless otherwise, if they have a timing GLS like a simulation view, they are not going to meet
So
and greet all different combinations, right? So there is
okay.
timing
So
GLS
now
is mhm,
I think I understand now what the problem. Actually, the problem statement need to be very crisp and clear, because we have now, at least I am trying to understand what you are proposing or saying.
mhm,
Because chiplet level, it's for us, right? Chiplet is just a hardware. I mean, it doesn't matter whether you call it SoC or you call it chiplet, because just having
right.
done chiplet, and just the difference is it can be in different process technologies and mature technology. We have chiplets in that. So basically, I don't see closing DFT GLS at SoC level is very different than closing DFT GLS for chiplet. But the problem is SIP level, and that I understand. I can understand now.
Yes,
But
right.
yeah, now the coming back to our whole group, right? It started with CDX. I mean, this may be a question for David and all. Is CDX going to be extended to the SIP level? Then it makes sense, because SIP level, our audience will be very limited. I mean, right now,
Did you say
chiplet,
did you say chiplet level or SIP level?
no, SIP level, SIP level.
Yeah.
Because what we are trying to address, our first problem in the CDX is various chiplet providers will have different chiplets, different things. So they need to talk the same language. So CDX came into it, actually solves the problem of integrating and getting chiplet
I
vendors 1, 2, 3.
Yeah,
But
I'm from my perspective, I'm feel pretty strongly the answer is no to that. I mean,
okay.
we're
Because
not getting into defining test standards,
Yeah.
you know,
yeah,
for the chiplet. What I would
correct.
that's I mean, that's a mini sub industry, right? I mean, there's
Yeah.
IEEE standards with teams of people spending years doing that. And, we've got a small
Yeah,
team that meets once a week for an hour. So way too ambitious.
I think
To,
you've got more
correct.
chance of doing it
what,
than
what,
doing it at the
what,
IEEE.
Yeah. So
exactly.
basically, I agree with
So
you, Tony. The reason is,
so
uh,
again, what I'm trying to say is let's assume, that those committees are doing that and defining these methods. And those methods, I mean, we can make recommendations. We say, well, based on the standards that are out there, we recommend that chiplet providers use standard A, B, and C, for 2.5D and use these standards for 3D. And, but, at the end of the day, it's a recommendation. What we should be doing in these formats is describing the methods that have been implemented in those chiplets in the machine readable format. And that information would give the information that a top level SIP level test engineer
I
would
think at this
need to
point, the
start even
machines can read
thinking about
everything.
how they're going to test this whole system, right? The first thing is to understand what's inside, but just like a board designer, they're not looking inside the chip. All they have is boundary scan. Now, I think boundary scan is probably not sufficient for a SIP level. I think we need to do more than simple boundary scan checks to check
connectivity check. So Stony, actually for us, the from whatever clients we are talking to, our devs, mainly we asked for access to the DFT pins internally. We will get a known good die, and then we are mostly focusing on connecting, checking just the interconnects. For that, the interconnect DFT for high speed and all that is done in another IEEE standard meeting. I think I mentioned it to you. And that's where
I think that's what the industry,
the
EDA industry would like, and chip providers would like. I don't think the end product companies, certainly automotive and Mil Aero, I don't think we're going to be able to get away with that. Known good die is necessary but not sufficient. So
that I agree.
need to do
That's
that connectivity checking to make sure everything is hooked up correctly in the package. But for many applications, it is a requirement for automotive that you're actually checking each of those components.
So that's why access to 1838, implement 1838.
Right.
And because in addition to 1838, you're talking about 3405, right? Which is still being developed.
Yes, that's right. Yes,
3405. Yes. So that's what I was thinking when this whole discussion started, because SIP level, the IEEE is already working, but I'm not sure this machine readable stuff will scale to that SIP level. I'm not sure.
So are you saying right now that people are not doing testing in the field, or not doing final testing? I know that's not true, because
No, I'm not saying that. I think the whole purpose, I'm just focusing for this test design kit charter. What is actually the next thing? That's why I wanted to make sure inside Chiplet. It has been demonstrated in the CDX ML format, and I think we gave some input to David about what pads and all that stuff.
So I know that people designing these chips have the ability to be able to test all the chips inside, right? So,
yes.
Are they using standard IEEE stuff, or are they doing custom stuff to be able to do that?
Or through TSV, a direct access to every chiplet.
So, say again?
Or direct access to every single chiplet.
Well, that's not really practical.
I know. I'm just saying, if anybody, even I would like to know what are they doing right now. Because 1838 is also not, it's still in, not everybody has implemented it. And high bandwidth memories, 3D stack, they are already out. So
yeah, well, high bandwidth memories, there's specs that handle that, so I think those are getting tested. But so I think by there seems to be quite quite a momentum in the industry to go with IJTAG, where you just have a simple JTAG port, and all your patterns are actually running through that. So you're decoupling the pattern problem, and then you're sending those patterns through the simple IJTAG ports. Internal, if provided you write that have the right patterns, you should be able to test the guts of the chip and get that information back. So if those methods are used, then at the SIP level, we just need to know, where those pins are and have a mechanism that, how do we get to those? Do we bring out those IJ tags separately for each of the chips, or do we daisy chain those? That's the way I think we should be thinking about this. And just stay outside of the chiplet. We don't want to go inside the chiplet. We should make recommendations to make sure that they're testable, and then just provide a concise way of describing the test IO and maybe timing information. How fast can you run those, and where's the clock, and all the relevant information that a knowledgeable test engineer would be able to generate the patterns at the SIP level. The chiplet vendor, it will have to provide more information to that SIP designer in order to generate that. And it's going to have to be, an IP deliverable that presumably needs to be encrypted, just to make sure that, they're not providing the ability to reverse engineer that design. And I think those methods exist.
Yeah, it's sounding reasonable to me. I'm not an expert in test, but it seems to me that there are two kind of similar problems to think about. One is you have a hard IP provider trying to provide IP for an SOC. And you think about, okay, so what kind of test info do you need, and what standards are there for providing that test info for that hard IP? And then on the other extreme, you have a bunch of chips on a board, and you want to understand what are the test ports and everything for those chips, so that you could do a system level test. And now that we're putting the system into this 2.5D or 3D package, it seems that you're kind of combining both of those things. And so there probably are a lot of standards available at both of those extremes. And now we need to think, okay, so what's missing to enable this kind of system in package implementation, right?
Yeah. And right now, a lot of these chiplet vendors, they're saying, no, we're not doing that. We're testing them and providing us no good die. And we need to be pushing back and say, no, that's not going to work. Nobody's going to buy your chiplet if you can't test it. Or maybe somebody will buy it, but you'll never get that into an automotive or some high secure type application that will not fly.
So
we
at
can't force
at
that.
this level
But
also,
if I'm a chiplet provider, I say, do we support this test method? Basically, am I providing the ability for a SIP level integrator to test my chiplet in at final test and in the field? And if the answer is no, then it's up to the end customer to decide, well, I can't use that chiplet because I have to be able to test that.
so yeah, so at after integration or after actually putting it assembly, you should be able to get to every chiplet.
Yeah.
For the final out of the door, like high volume production. That's definitely there. Known good die is just to actually eliminate the cost of bonding it. I mean, see, if wafer to wafer bonding, you don't even get that chance to do like known good die. We don't know how many die. They just are going to bond it. It's possible that many of those are not actually known good die either.
Right.
So,
So
so support for
think we're-
1838, isn't it? So
Yeah.
every chiplet should have support for 1838.
So because that's exactly what I agree, right? I mean, system level test has to be there. There's no doubt to make it known good package, right?
Yeah.
So there's no doubt about what Tony and you are saying. I mean, I think this either we have to mandate from each chiplet vendor to comply to 1838 and 1687 internally. So that 1687 also can be triggered from 1838 with a P-tap and S-tap. So that's the only way right now. And P34, when it comes out, it will also be needed for high-speed interpretation.
Yeah, I
Absolutely.
you need to be a little bit careful because, if you're selling VRM, do you need 1838 for that? No, right? So, a lot of these things are not applicable depending on what the chip is doing. But if
Correct.
it's a simple SerDes type interface, so we can't, so I think the provision is, what does the chip do? So provide a functional model. I think that is a requirement. It hasn't been a requirement, or at least it hasn't been enforced in the standard part world. So board designers are not doing any functional simulation. That's not going to fly in the packaging world. So again, the chiplet vendor needs to fill out that checklist of what tests are available, right? We have the checklist right now. It's in the CDMXL. It's a simple yes, no, right? And ultimately it will be the person who's going to purchase those chiplets, and if they need something, if they need the ability to test it and that's not supported in the chip, then they're not going to buy that chiplet. But we can still say, hey, buy it at your own risk, but we don't provide this feature. So I think the format needs to be able to handle that. And then assuming it has the recommended test structures implemented, what information in addition to just these are the test method can we provide in this format that will help the system integrators develop a SIP level test implementation. So they're going to have to run DFT tools and be able to generate the test. There's probably some timing checks that need to be done at the IO for these test pins, and that's what I believe we're trying to accomplish in this TDK. So I think we should go back and maybe articulate this in the overview of the spec, and then we should go back and revisit to make sure, see what's missing, and start. We always need to ask ourselves, is this an internal chip thing, and if it is, then we need to go back and say, all right, we don't want to go inside the chip, but maybe there is some information that we would need to provide inside. I don't know enough about this, but we don't want to provide a format that a chiplet designer is used to test their chip. That's beyond the scope, in my opinion. What we're
So
trying
one question for Tony, Rajesh, anyone. So every tab has its own security. So chiplet providers need to give it to OSAT like us, because I'm thinking from like only assembly and we are just going to assemble it and run it and see if patterns are working. So how would that work? I kind of like lost you over there too, little bit, when I'm writing point by point. So,
Yeah, I mean, we talked about security in the original white paper, and we agreed security is important, but there's other groups at OCP that are looking at that. So we opted not to bite off on that, but it is something that needs to be addressed. So what we put into the BART model was just provide documentation in terms of what security agents are available, and but that's today. I think I mean that is the plan of record right now, that we're not doing anything specifically to support security, but simply documenting, what security agents, if any, are provided for that.
okay. Understood. And Tony, one more thing, since you mentioned it, do you know how people are doing it right now? How they are testing, like final or high volume manufacturing, or the final test floor? How they are testing?
I don't personally know. I mean, the only chips that I were involved in, were, HBMs, and those standards, are pretty well known. We did one chip that we developed our own IP that was, we called it a chip-to-chip interface. Eventually, that ended up being the HBI2, I think, standard, but it's really hasn't caught on in the industry. It's kind of a bow-like type structure, but we the chip level patterns, basically we just test it, kind of at the system level, and that was just a way of connecting the two chips. So we weren't really, explicitly doing anything to check those interfaces.
So because I think to answer your first question, which Tony already addressed, but my 2 cents is security is actually doesn't fall into test or DFT domain, because there are security teams who define what is this format, what is requirement.
Actually, Rajesh, no, that was not my question. My question was because every tab, like to unlock it, you have this security.
Oh yeah. That was, I
mean.
think. Yeah, I understand. So, but I think you understand. You asked the first question, which I agree with Tony also. I guess of DFT, its features and all. We do not basically define any security architecture for our stuff. We just depend on what security architect is going to define. And your second question, I just had to opportunity to see one implementation for test and all. So I think it is same as challenge response, whether you do encrypted things and then you unlock the JTAG, and then only you will be able to execute the patterns. And the other thing I have seen is for memories, for example, the very, very secure memory is defined by the security team. You'll need to ensure that only reset sequence will have certain code, which only when that comes, you'll be able to unlock you have to flush the memories so that there is no sensitive data,
Okay,
all that stuff,
okay.
So that kind of stuff is implemented, but that's again inside Chiplet.
Right.
At system level, we do not have any control over security.
Yeah, but Rajesh, actually, I'm little confused on this thing that, okay, you have Chiplet. Finally, we have to do that. We have to run MBIST. How is of a particular chiplet through 1838? That sequence. I'm just trying to understand.
So 1838, we'll have to access the whole stack, whether it's 2.5D or 3D, through 1838 PTAP, and then whatever the level, let's say it's a 5 stack thing, we have to go to number 4, and it's a secure. Then that particular serial tab may have to be securely unlocked, and then only we'll able to run this.
Mm.
That is,
Like
I'm
a
thinking
regular
on the top
test.
of the top. Yeah, yeah.
Like a
I'm
regular
just throwing
test.
some
Okay.
my ideas. So
Of
that's the
course.
reason.
Okay.
Okay, okay.
Yeah.
I think I need. Okay, I need to drop.
Yeah.
Yeah, we're
Yeah. Thank
at the
you.
top of the hour. So thank you, everyone. This
Thank
was
you.
a very good discussion. We'll continue in 2 weeks.
Yes, I sent it to you, the path.
Thank you.
All right,
You
thanks,
should be
everyone.
able to access it from there. So I'm
Yeah.
All right.
Thank you.
Thanks,
Thank you,
everyone.
guys.
All right.
Thank you. Bye.
Talk to you guys. Bye.
Yeah.
Bye.